Just like when solving two-step equations, I can solve more complicated equations using inverse operations. When I'm solving using inverse operations, I always need to do so in the reverse order of operations. That means it can be really helpful to trace through the original order of operations so that I can then work backwards in the reverse order. For this first example, I could use a different strategy. I could use the distributive property first and then combine like terms. And that strategy is great. It is completely acceptable. So unless I say, solve this equation without using the distributive property, go ahead and use the distributive property if you like. However, in this notes page, I'm going to go over the other strategy of solving just using inverse operations. So when I'm solving using inverse operations, the little mini flowchart can be really helpful. I'm going to use the top of the flowchart to trace through what's happening to the variable in the equation, and then the bottom of the flowchart to figure out my inverse operations. This flowchart is not required work. I will never say you have to use a flowchart, but it can be really helpful. All right, so in my equation, the first thing that's happening to x, according to my normal order of operations, is I'm subtracting 2. I do what's inside the parentheses first. The next thing that's happening to my variable in my equation is I'm multiplying x minus 2 times negative 3. Finally, the last thing that happens in my equation is I add 4. So according to my normal order of operations, I subtract 2 from x, I then multiply that by negative 3, and then I add 4. That means when I work backwards, I'm going to perform the opposite of each of these operations in the reverse order that they happened in the equation. I'm going to go ahead and trace that through in the bottom of my flowchart. The first inverse operation will be the opposite of adding 4. So my first inverse operation will be to subtract 4. Next, I'll do the opposite of multiplying by negative 3. I'll divide by negative 3. And finally, the opposite of subtracting 2, I will add 2. So again, flowchart not required, but it can help me as I solve algebraically. This first inverse operation gives me my first step. My first step is to subtract 4 from both sides of my equation. Negative 3 times x minus 2 plus 4 minus 4 leaves me with negative 3 times x minus 2. On my right-hand side, I have negative 5 minus 4, which is negative 9. Next inverse operation is going to be to divide both sides of my equation by negative 3. Negative 3 times x minus 2 divided by negative 3 is just x minus 2. So dividing by negative 3 undoes this times negative 3. On the right-hand side, I have negative 9 divided by negative 3, which is 3. Final inverse operation, hopefully you don't need the flowchart at this point, is to undo subtracting 2. So I'm going to add 2 to both sides of my equation. X minus 2 plus 2 is x. And then my solution is 3 plus 2, 5. The solution to this equation is x equals 5. When you're solving a more complicated equation like this, it's really a good idea to go ahead and perform the check, at least mentally. Does negative 3 times 5 minus 2 plus 4 equal negative 5? Does it? I sure hope so. Negative 3 times 3 plus 4. Negative 9 plus 4. Oh, my handwriting. Yes, negative 5 equals negative 5. So I have confirmed that 5 is the solution to this equation.